Hello, welcome to Marsh Mathematics, and this video on differentiation is about the quotient rule. Okay, well, we're going to have a look at a typical sort of exam question that involves the quotient rule, finding a turning point or stationary point. Now you can tell it's a quotient because y is equal to a function of x divided by another function of x. Okay, and so to find the turning point, we need to find out what dy by dx is. Now you're given the quotient rule. Quotient actually just means it's just another name for a fraction, really. You're given this rule. You're not given the product rule, but you're given the quotient rule. Okay, so what we want to be able to do is really just to be able to use it. Okay, u and v are the two functions of x, so we let u equal x squared and v equal 1 plus 2x cubed. So the first thing we do, we need to find du by dx, so we differentiate that, get 2x, and then we need to find out dv by dx, which is going to be 6x squared. Now all we need to do now is substitute, okay, substitute into that formula. Now I'm going to expand and simplify the top part, but leave the bottom part. Don't bother expanding the bottom part at all. It's just leave that. Normally you can just leave it. It's the top part that we're going to be interested in. So I've expanded the bracket and simplified it, okay, and even factorized it to get the 2x out. So it's really important that if you're looking for dy by dx, okay, we're trying to find out when dy by dx is equal to 0, it's important that you factorize the top part, okay, because it's the top part that we're going to be interested in, okay, the numerator, because at stationary points we know, okay, that dy by dx is going to be equal to 0, so that whole expression, this expression here, is going to be equal to 0. So we're not going to be interested in the bottom part, in the denominator, okay, but we're just going to be equal to the top part, because if the whole of this expression here is equal to 0, this expression here, it means that the top part must be equal to 0. Remember, this cannot be the denominator cannot be equal to 0, because then it'll be dy by dx will be equal to infinity. Okay, so we're not interested in that. So we solve, really, what you're really solving is this. And that's what was important to factorize it. So that means we're going to get x equals 0 or x equals 1. Now what we do, we substitute back into the original equation to find out the coordinates. Okay, so we just substitute back into the original equation with x equals 0 and x equals 1, and we're going to get the coordinates of the two turning points, okay, which I've got here. Okay, now it asks in the question, if you look, go back a bit, determine their nature. Now you should know that to determine their nature, the normal procedure is to find d2y by dx squared, okay, and that's a normal procedure, but because dy by dx is quite complicated here, the best way to do it, okay, you could find the second derivative, so you'd have to use the quotient rule again, okay, but rather than do that, what you can do is set out a table like this, and you can look either side of the turning points, because the turning points are x equals 0, this one, and x equals 1, and you can look at the sign of dy by dx. So if you substitute, if you put a value in just below x equals 0, because these are the two turning points, yeah, turning point, so I've used minus 0.1 or any number that's just below 0, okay, and you find out that it's less than 0, it's negative, so that means that the gradient will go this way before the turning point. You know that it's flat when it's at the turning point. If you just go above greater than 0 but below 1, okay, because we don't want to go as far as 1 because that's the other turning point, we find out that the negative, the dy by dx is actually positive. Okay, so now you know that if it goes negative, 0 and positive, then that's a minimum point. Now if we just go we know that it's positive just before 1, okay, and we know that it's 0 at 1, and if we put a value in just above 1 into, remember, into dy by dx, we find that it's negative, so that must be, it goes positive, 0, negative, so we know that's a maximum, and that's how we establish the nature of those two turning points. Okay, just to as a matter of interest, if the bottom does equal 0 or tend to 0, then dy by dx will tend to infinity, and that means that the curve will be parallel to the y-axis, okay, because it'll have a gradient of infinity. So they do occasionally ask that, okay.